Well, here we'll talk about systems of equations and one of the first ways to solve these, called substitution. First, what is a system of equations? A system of equations is a collection of two or more equations, each of which should contain one or more variables. We can have something like 2x plus 3y equal to 7, or 4x minus y equal to 0. This would be a single system of equations. In particular, this one has two equations and two variables. We could also do x plus 2y minus 4y is equal to 9. 3x plus 7y, mess that up a little bit, that should be minus 4z. Plus 5z is equal to 0, and then 6x plus 8y minus z is equal to 12. This would be three equations in three variables. Our ultimate goal is to find solutions of these systems. So what is a solution? Solutions are values for the variables that are solutions to all of the equations in our system of equations. Essentially, we should be able to take this solution, substitute it in, and get true statements in not one, but all of the equations. Here we have this ordered pair, 3, -2, and we want to know if it's a solution to this system. So we're going to try. The first number is x and the second number is y, since we always want these in alphabetical order. So we have 4 times 3 plus 3 times -2 for our first equation. 4 times 3 is 12, minus 6, which is equal to 6, which is exactly what the first equation should be equal to. For the second equation, minus 3 times x, which is 3, plus 2 times y, which is -2. That'd be -9 minus 4, which is -13, which is exactly what we needed. Therefore, yes, this is a solution to this system. Here we have a system of three equations in three variables, and we want to know if 1, 2, 3 is a solution. So this time we have x, y, z. Our first equation, this is 3 times x, which is 1, minus 2 times y, which is 2, plus 4 times z, which is 3. This is 3 minus 4 plus 12, which is equal to 11, which is exactly what we wanted. Our second equation, -5 times x, which is 1, plus 3 times y, which is 2, minus z, which is 3. So we have -5 plus 6 minus 3, which is equal to -2. So that also works. We now need to check the third equation. 7 times x, which is 1, minus 6 times y, which is 2, plus 4 times z, which is 3. 7 minus 12 plus 12 is equal to 7. However, it was supposed to be equal to 8. So this does not work. It is not a solution. If we want something to be a solution, it needs to work for all equations. And if it fails for just one of them, it is not a solution. Next, we'll discuss the first method for solving these systems of equations, called substitution. And we'll have 5 steps. The first thing we do is pick one equation and solve for one of the variables. It doesn't matter which equation you pick or which variable you solve for, as long as you do one variable in one equation. We then substitute this value into the other equation, and whatever variable we solve for in the first equation, or in the first step, we're going to take our opposite equation and change that variable to this expression that we found. Our third step, we want to actually solve this equation that we now have. The fourth step is then to find the remaining variable that we haven't been able to solve for yet. And then finally, we should check the solution. So now we'll do a couple of examples demonstrating this process. We now have this system of equations, x plus 2y equal to 5 and 3x plus 4y equal to 9. Our first step says we should pick one equation and solve for one of the variables. Ideally, we want to pick an equation and a variable that already has a coefficient of either 1 or -1. In this case, we're going to solve the first equation for x. So we have x plus 2y equal to 5, and we will subtract 2y from both sides. This gives us that x is 5 minus 2y. I then take my second equation, which is 3 times x. But instead of x, I'm going to write this thing that we just found, 5 minus 2y, plus 4y equal to 9. Multiplying out, this is 15 minus 6y plus 4y equal to 9. We can combine the y terms and get 15 minus 2y equal to 9. Subtracting 15 from both sides. On the left, we get -2. On the right, 9 minus 15 is -6. We then divide by -2 to see that y is equal to 3. So we have our first variable. We then go back to the solved form to find x. 5 minus 2 times y, which we just found to be 3. Therefore, x is 5 minus 6, which is -1. So our actual solution, -1, 3. One more example. We have this system of equations. And once again, I suggest picking an equation and a variable that has a coefficient of either 1 or -1. In this case, I'm going to solve this second equation for y. We'll add 4x to both sides. And this gives us -y is 3 plus 4x. Multiplying through by -1 tells us y is -3 minus 4x. We then use the first equation, which says 3x plus 2y, but instead of y, we'll write this expression we just found, -3 minus 4x, equal to 4. Multiplying out gives us 3x minus 6 minus 8x is equal to 4. 3x minus 8x is -5x. Minus 6 is equal to 4. We can add the 6 to both sides. On the left, I'm left with a -5x. On the right, 4 plus 6 is 10. We can then divide by -5 to get that x is -2. We can then use this expression for y to solve for y. -3 minus 4 times x, which we just found to be -2. That gives us -3 plus 8, so y is equal to 5. Therefore, my solution, -2, 5.